Hello, everyone. Welcome to an introduction to Python. My name is Thomas Chardy, and today I'll be walking you through kind of the basics of Python, how it compares to R, which we've been learning about a little bit already, and kind of why it's important to even understand or know Python in the first place. So to start off, let's talk a little bit about the basics of Python. So Python is a high-level general purpose programming language. So R is tailored a little more to statistics and data analysis at its core, whereas Python has a little bit wider of a capabilities it's able to do. So you'll see it used in data science, but also you'll see it used in web development, application development, machine learning, and much, much more. It's very popular nowadays. I believe it is the most popular programming language out there currently due to its easy syntax, very large community, and the extensive set of libraries and support that exists out there for it. So similar to R, there's a couple basic data types for your variables. So these can include integers, booleans, floating points, and strings. You can see in this table down below here. Here's an example for the different ones. So an integer is just your kind of standard non-decimal number, whereas a floating point is a number that can be a decimal. Boolean is representative of a true or false value. And then we have a character, which is just a single letter, and a string, which you can think of as multiple letters concatenated together. So this could be a word, a sentence, or something larger. And similar to R, we're able to conduct some basic operations in Python. So here we have two code chunks representing some basic functionality inside of Python. So in the top code chunk, what we're able to do is we set our variable x equal to 4. And then when we check that variable type, it shows that this is an integer type. So one of the non-decimal type numbers. And then below, we give a demonstration of how we can take our variables and apply an operator between them. You can think of an operator, so something such as addition, subtraction, multiplication, etc. So basically, applying some kind of operation between two variables. So in this case, we create a second variable named y. So we have x equal to 4. We have y equal to 4. We can add x and y together, and you can see at the bottom that it returns 8. Again, similar to R, we are able to have control flow statements. So these are basically ways we can implement logic into our code. So in this example here, we can do things such as an if-else statement. We can also do things such as loops, for loops, to iterate over a series of numbers, or maybe you have a list of elements that you want to write your code to go through. So in this example here, we have a simple if-else statement. In the first line, what we do is we set our variable x equal to 10. And then in that second line, we're checking if x is divisible by 2. And if it is divisible by 2, we're going to print that x is even. If it's not divisible by 2, we'll print that x is odd. In this case, since x is set to 10, it is divisible by 2. And we see at the bottom that this code chunk returns x is even. And kind of the other big component and kind of the basics behind Python, and I think a lot of programming languages in general, is you have these variable types, you have control flow statements that allow you to manipulate your variables through logic. And then lastly, what you can do is you can combine all of these variables and operations and logic into kind of these wrappers, which we'll call a function here. So this little tiny thing that you can repeat over and over again. And that's a lot more flexible and robust than writing out all of your code in a repeated fashion. So in this case here, what we do is we define a function using Python. So the syntax in Python is to write def, and then the name of your function. So in this case, we write def, and then func, which is the name of our function here, and then x is the input parameter into this function. So what we're giving the function inside of the function itself, we can see that we return x times 4. So whatever value we give this function here multiplied by 4 should be our answer. When we call this function down below, what we do is we call function, we insert 2 inside of there. So our expectation is that we now have 2 times 4 being returned by the function. And we can see at the bottom of the script, this holds true yet again, where we get a return of 8. So by creating these different functions, which can become increasingly complex, we can do something very simple, such as just taking a list of numbers and maybe multiplying them by 4 in this case. But we can also do things that are going to be increasingly complex down the line, where maybe you have a function that takes a list of images, loads them all up, applies some kind of processing to it, and then feeds it into a model or a machine learning model that you're attempting to use. So that's kind of the introduction to Python. In that case, I just wanted to demonstrate that there's a lot of similarities between Python and R. Once you kind of understand one programming language, it's very easy to, or a lot easier to translate that knowledge over to a new programming language. In my opinion, it's most difficult to learn your first programming language. But once you know one, once you understand kind of the concept of we have these variables that I can set, we can manipulate our variables using logic and wrap these all inside functions and design, these nice code chunks to do what I'm maybe some data analysis or data science that we're trying to do. These skills are all very transferable. You'll just have to kind of learn a bit of the differences and how to exactly write the syntax of the code and maybe what certain types of variables are called, etc. So in this slide here, we're just giving a kind of a general overview of the difference between Python versus R. So Python is a high-level general purpose programming language. You'll see it used in a lot of different places for a lot of different tasks. So developing websites, developing applications, doing data science, etc. Whereas R is built primarily for statistical computing and graphics. So R has really great visualization libraries to produce very nice looking plots, and does a really great job of doing kind of data manipulation and statistical analysis tasks, I think in a much more coherent fashion than Python might. So some of the advantages of Python is it's production ready. So Python, typically you're able to deploy the code that you write into web applications or maybe mobile applications much easier than with R. As well as I think it has kind of advantages in the breadth of libraries due to the large community. So it kind of has better libraries that support things like natural language processing, as well as computer vision. R, on the other hand, actually, in my opinion, um, the syntax and kind of the readability of it is a bit easier than Python. Um, there's kind of superior libraries for statistical type analyses, such as the analysis of time series, and CRAN, which is kind of the overarching organization that reviews packages and libraries produced by other people, has a much more comprehensive screening process than Python. So any library that you import into your RStudio and start using, you can expect that to be compatible with all the other libraries that you have, and you won't run into any configuration issues. Whereas Python, there's a lot less management in terms of the libraries that exist out there. So you'll often run into things such as maybe the version of one library is not compatible with another library, and you have to go in and debug, and that can be quite a headache. Some of the disadvantages from each sides. Python, I think, is a little less intuitive in terms of the readability of the code, and the visualizations are a little harder to make as nice looking as R. Whereas in R, um, you kind of lack a lot of the robust image analysis libraries that exist out there. So when it comes to things such as a lot of popular tasks such as natural language processing, so using kind of language and machine learning or images and machine learning, you're not going to find kind of the support that you might be looking for using that. So let's go into kind of some syntax and functional differences between how these two languages exactly work. So there are some minor functional and syntax differences, and I think understanding some of these differences between the two languages will help you kind of translate your knowledge better, and better understand how to use each, and see that they're very similar overall. There's just some kind of slight modifications that you'll have to make when you start maybe coding in Python versus R. So we'll talk about variable assignment first. In the example pieces of code you saw before, you likely noticed that whenever I set a variable, I would use an equal sign. So in this case, for setting the value of a variable here called pyapples, we use the equal sign to set pyapples equal to 5. If we print out pyapples at the bottom, it returns 5. In R, we have this variable called rapples here, where you see we use this kind of arrow notation to denote the value for that variable. And again, when we print that out at the bottom, it also returns 5. So each behaves in the same exact way. However, in Python, you'll want to use an equal sign for assigning a variable a value, whereas in R, you'll want to use that arrow syntax. I think another one, and this is one of the, it's very minor, but very easy to get tripped up over while you're alternating between the two, and something that I've messed up plenty of times. But Python indexes from 0 while R indexes from 1. So what does this mean? So you can see that down below, I create a Python list called PyList here. It has 3 elements inside of it, 1, 2, and 3.0. And what we do is we show index 1 of this list. So we're printing out whatever is in the first index of the pie list. And you can see in this case, it returns 2, which if we look at the list is actually the middle element or the second element. This is because Python starts its index from 0. So that means that the 1 in the list actually is index 0 that we need to refer to. In R, however, it starts its index from 1. So we create the same exact list down in R below. And when we return index 1 of the list, we can see that it returns 1. So calling index 1 in Python returns the second element of the list, whereas calling index 1 in R returns the first element of the list. And this will be something important to remember as you alternate between the two languages. You always want to make sure that you're indexing from 0 if you're trying to get the first element from a Python list. That means when you write your loops, where you're iterating over multiple elements inside of a list, you always want to start from 0 if you're trying to capture every single element, whereas R, you'll want to start from 1. Vectors are another kind of a sort of data array that differs slightly between R and Python. So R actually has a native data type to create a vector, which you can think of kind of as a array of numbers. So in the bottom here, if we look at the R vector, we can see that we use this C notation, and inside the parentheses, we place our numbers. So C012 creates a vector of 012 inside of R. And then we can return an index from that vector. So in this case, we return the first index, and we see that returns 0. In Python, however, Python does not have a native data type to represent a vector. It has a list, but this is slightly different than an actual 1D array. So in this case, what we'll actually need to do is we'll use a very popular library called NumPy in Python. So libraries are essentially Python code that's been developed by third-party organizations or individuals that you can import and use inside of your code. So rather than you needing to write all of the logic to figure out how to organize a vector and represent that in Python, we use external libraries a lot of the time, and we'll use this in R for many tasks as well, where we'll load in this external library, use the functionality it has to accomplish kind of the needs of our current coding or scripts. So in this case, almost always in Python, when you're doing data analysis, there's 2 primary libraries that you'll be using. One is NumPy, which you can think of for kind of array manipulation. And the second one is pandas, which helps you create data frames and analyze, manipulate, and work with kind of data frames. So in this case here, what we're going to do in order to create our vectors, we're going to import NumPy, and we're just going to name this NP in this case. And we can see that we create this vector in Python. We just set it to be np.array. So we're creating a NumPy array, and then we add in our same exact elements of 0, 1, 2 here. And again, if we return actually the first index from our Python vector, we can see that we return the second element due to the indexing, which we just talked about in the previous slide. Next, we'll talk a bit about data frames. So data frames are ways or kind of to basically represent tables inside of your code. So any sort of data structure that has columns and row values, which is very common in spreadsheets or data tables. A lot of the time you're using to manipulate and kind of track your samples within data analysis. So similarly, R actually has a native data frame. So you can see at the bottom here, all we have to do is we have to call data.frame of the vector that we just created previously. So in our case here, what we're doing is we're creating a data frame where each row corresponds to one of the elements from the vector, which is 0, 1, 2 that we created previously. In Python, we can basically do the same exact thing where we can create a data frame using that vector that we created. However, rather than having a native data type inside of Python, so rather than Python already having a data frame type of object that we can use, what we need to do is we need to import this pandas library. So we'll call it import pandas as PD. So we're importing pandas, naming it PD. And then what we can do is use the PD library, so PD.DataFrame. So we're loading the data frame functionality from pandas, and then we're creating that pandas data frame using our Python vector from before. So at this point, what we've gone over is here's the basics of Python, how it relates to R a bit. Here's some of the key differences between Python and R. Both, I think, are very powerful languages for doing data analysis, but you might stumble across as you kind of work through your work using R for the most part, that maybe there's code written in Python that you actually want to be using for some of your analysis. Maybe R doesn't have the functionality that you need, or maybe a solution that you found for your problem actually uses Python code. So how can we go about this in an easy way? Um, Today, RStudio actually supports you being able to use kind of Python within RStudio itself. So you can actually go in and write Python code as long as you indicate your code chunk to be using that, and things will work appropriately. But we can also use something called the reticulate package, which is an R library that allows kind of provides a set of tools to operate between Python and R very seamlessly. So what does this allow you to do? This basically allows you to call and write Python code inside of R from a variety of ways. So inside an R markdown file, we can create a code chunk that's actually a Python code chunk where we just write pure Python code inside that chunk, run it, and it runs just as if Python would run inside of a different IDE. We can source Python scripts. So if you have a script written that has Python code inside of it, you can call that directly from Reticulate and run an entire Python script through that. Or you can, you can also import Python modules. So if there's certain libraries in Python that accomplish tasks that you're interested in, you can load up those libraries, use the logic of that. And lastly, you can also use Python interactively. So you can run scripts. You can take a Python script that pre-exists and run the entire thing. However, inside of maybe an R Markdown file, you can also use Python in an interactive way where you're only running certain code chunks at a time. You're manipulating those variables, examining them, and kind of modifying them interactively. This package also provides a way to translate between R and Python objects. So say you create a data frame in R, um, and rather than wanting to save your data frame as a CSV file, then pulling up Python and loading that CSV file into a Python data frame, you can actually translate some basic data types between R and Python. So you can take an R data frame, translate it directly into a Python data frame. And similarly with matrices and arrays, you can do the same exact thing. So the Reticulate package is very powerful. It gives you a lot of interoperability between these two languages. And I think being able to use both these languages effectively will make you a very strong data scientist. Everyone has their preferences on which language they prefer to use. I think each kind of, as we reviewed before, shines in its own unique way. And it's kind of up to you to, I think, examine the task at hand and kind of select what might be the best solution for you. At the same time, I think it's important to learn the basics of Python at least, even if you decide to specialize in R, because it'll help you understand what maybe some of your peers are capable of doing if they're using Python, what limitations they might have, what limitations that you might have, and communicate with them effectively, kind of agnostic of these different programming languages here. So at the bottom, we're going to demonstrate how to use Reticulate. The first thing we need to do is load the actual Reticulate package. So this is an R code chunk here where we're just loading up the Reticulate library. And in my case, I'm just setting some of the error and console messages that it spits out to off just to make things look a little cleaner. So some of the basics inside of Reticulate, it's very easy to use it. So inside of an R Markdown file at the top, what you'll do is you'll have kind of your hashes to indicate the start of a code chunk. And next to that, all you have to do is write this kind of squiggly parenthesis, Python squiggly parenthesis, and that tells R Markdown that this code chunk is going to be using Python code rather than R code. So we can see inside of here, once we set that code chunk to be using Python, all we have to do is just uh, write Python code. So in this case, I set a variable to equal hello plus world, two strings inside of Python. If I print that out using the Python syntax, it prints out hello world exactly as if I was just working within kind of a Python coding environment. The one important thing to note is that when you create these variables inside of your Python quote unquote environment, they will not automatically be also inside your R environment. What does this mean? So if I write a code chunk in Python, as I did above, and I set variable a equal to something, this exists in kind of my pseudo Python environment within R, but it does not also exist within my R environment. So if you look at the second code chunk here, I'm actually checking if the variable a exists in my R environment. And we can see that if I check if a exists, it returns false. However, above, we actually set a variable equal to something, so a should exist. To get around this and to operate between these two languages, we can actually pass the variable from one environment to another. And this needs to be done if you want to go back and forth explicitly. So in the next code chunk here, what we do, this is an R code chunk, we can actually get the variable a if we type pi $, and then our variable name. So this is an R code chunk here. I write pi $a, and now we can see we're able to access that Python variable that we created before. The exact same thing happens in the opposite fashion with R. So if I set a value, a variable b equal to 5 in R, I will not be able to call that inside of a Python code chunk at all. What I have to do is explicitly type r.b, and that will return the variable that I set from my R environment. So that's kind of basic manipulation of different variables, how to interact and work between an R environment as well as a Python environment. However, we can not just do the basic functionality of, loading up Python variables and setting them and adding them together, but we can actually start to use kind of the unique aspects of Python through its own unique libraries that it possesses. So if I want to load up one of a Python packages, this top code chunk here, I have a Python code chunk. I'm importing the OS module from Python, which is kind of a default library that helps you understand directories and file paths. And then I can call os.get current working directory, get cwd, and that returns the current place where my file is sitting and where I'm working inside of. So this is pure Python code here. I load up a Python library. I call a function from that Python library, and this is all being run inside RStudio here. So I'm running Python code, getting the results from that Python code, all within my R environment. So the next example here is how we can call and use, so the above example is calling and using basically Python code inside of an R markdown file where we have an explicit code chunk that we say, this is a Python code chunk, make sure you're running Python code here. If we want to actually use it inside of an R script where we don't have kind of an explicit place to specify that this is a code chunk that should be using Python, we just alter the syntax a little bit. So in this case, what we can do is we can set an OS variable. So we create an OS variable inside of our R environment, and we set it to be importing that OS from Python. So basically the same exact thing as we do above, just a little bit different syntax. And then we can use that OS variable. So now that we have that OS library loaded, we can use that same $ syntax as we did before to translate between the two environments, run that current working directory function from the Python library, and we can see inside of our script, it returns exactly what we want it to using that Python logic. So we can use the kind of unique libraries from Python to do classic Python manipulations inside of R. So here's an example kind of in this last code chunk where we load up that NumPy library that I talked about before, NumPy being this library built to kind of analyze and deal with matrices and operations. We load up NumPy, we create an array inside of R that's just numbers 1 through 4, and then we sum the entire array. And here we can just see that we're repeatedly using Python functions. So we're using numpy.array in this case, and then we're applying cumulative sum, which is a Python function, to that A array that we created. And lastly, what we can do is we can convert that object from Python back into R and print that out. So in this case, at the bottom, what we do is we load up our Python library, we create a variable, a Python-based variable, an array, we sum that all, and then finally we convert that Python kind of data frame back into an R object to examine and use. And kind of the last topic from Reticulate that I'll cover is we can also design and run entire functions, Python functions. So I've demonstrated basically basic variable assignment, loading libraries, and kind of using those to manipulate variables inside of Python within R. But we can also write entire Python functions. And you have one option is to write your entire function as a string. So in this case here, what we do is we set an R variable called PyFunction equal to a string that just contains the logic as if we were writing in Python. We can call PyRunString, which is a function from that reticulate library, on top of that variable, and it will print out hello world or call that Python function that we described within that string. We can get even more complicated here and call an entire Python script or a .py file and run that script using Reticulate by using the pyrun file, which is just another function from the Reticulate library. So you can see from before we have py2r, which is translating a Python object to R. That's part of the Reticulate library. We have pyrunstring, which is running a Python function from a R string. And then we have pyrunfile, which is basically taking a file path to a Python script and running that inside of R. So this is a quick glossary here. Throughout kind of this presentation, there's a variety of different topics that we covered, and I think some specific language to exactly data science, Python, R, etc. So if you need any clarification on kind of what any of these terms that I talked about are, you can find that all in the glossary inside of here. And kind of lastly, these are some of the acknowledgements and further resources. So if you're interested in learning a little bit more about Python, you can click on that first link. If you're interested in learning more about the differences between R and Python, as we discussed, you can click on that middle link. And then lastly, if you're looking to use Python more inside of RStudio or your R scripts, an interface between the two, that third link will bring you to the Reticulate documentation and library, where you can learn a lot more about how powerful Reticulate is. Within our research group, we've rewritten entire Python packages into R and provided, R versions of a Python package using Reticulate. So it's a very powerful tool. I think it unlocks a lot of capabilities, and I think at the end of the day, it helps you better understand Python, which will make you a stronger data scientist and better able to communicate and understand what you're exactly capable of doing, as well as being able to interact with kind of data science peers and accomplish all the goals that you have. So that concludes my introduction to Python. I hope you learned something from this all, and if you have any questions, feel free to reach out. Thank you.